Hello, I welcome you all to this another interesting screencast. And the problem reads: if Fa is equal to 40 kilonewtons and Fb is equal to 35 kilonewtons, determine the magnitude of the resultant force and specify the location of its point of application on the slab. In the second case, if the resultant force is required to act at the center of the slab, determine the magnitude of the column loadings Fa and Fb and the magnitude of the resultant force. Both these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. Right, we can solve these particular problems by using both the scalar or the vector analysis method. Or if you want to, you can always combine the two. Right, for me, I'm going to combine the two approaches. So let's straight away start working on our problem. So we have let me call this as case 413. There we go. In this particular case, we have been given Fa is equal to 40 kilonewtons and Fb equal to 35 kilonewtons. So let's find the summation of forces in the z direction. This is going to be equal to FRZ, this resultant in the z-axis, minus FA. I'm saying minus because they are in the opposite direction of our zoomed axis, minus FB, and then minus, I want to add the rest, 30 plus 90, that is 120 plus 40, that's 140. Great. And therefore, our FRZ, if we are to replace these values of Fa, and if we replace this, we replaced it here, and we did the same, also did the replacing here, then we find that this gives us a minus, that's 140 plus 40, 180 plus 35, that is 215 kilonewtons, right? 80. Great. So then let's find the summation of moments. So this, we can write it as a vector. We'll say FRZ as a vector. This is just going to be equal to minus 215k. So let's find the summation of moments as a vector, the resultant moment. Let's start with the x-axis. So for the x-axis, I'm going to again write this with the unknowns. We're having a negative, okay? We're having a negative using the right hand thumb rule, and I'll represent it as a vector, the full expression. So we have Fa as minus Fa by the lever arm, which is 6.75, minus Fb by the lever arm, which is 0.75. Okay, then minus, let me sum up everything. So we have 30 by 0.75, we have a 90 by 3.75, and we have a 20 by 6.75. Alright, so we have a 495, right? The 495, this is I. So plus, let me just check it again, 30 by 0.75 plus 90 by 3.75 and 20 by 6.75. Alright, 495. So let's check the other side. The other side will have positive, so we'll have Fa times the lever arm. The lever arm there, it is 5.57, and Fb also is the same 5.75 and plus. Let me sum up the rest. We have 30 by 0.75 and then 90 by 0.25. I mean 2.5 plus 0.75, and then a 20 by 0.75. So we have a 330 in that direction, J. Great. Then let's assume we have our resultant just at that unknown. We have the resultant, let's say they are like so. We call this as our resultant. All right, this is our resultant F R Z, and then let's call its position from the reference there. We call them from the reference is our R resultant. This is the moment arm. All right, and this position is just arbitrarily, just x comma y. Its position is arbitrarily. There we go. Its position is arbitrarily. Okay, so that position is equal to, this one is d, we'll call this as dx, we'll call this as dy. All right, and therefore our R resultant is just going to be equal to, this is just the moment arm for our assumed resultant force. Let's call this as dxi plus dyj. Okay, so now what we need to do, we need to cross R with our force. So we'll say R resultant cross FRZ resultant. This is going to be equal to dxi plus dyj cross minus 215k. This is going to be equal to, instead of drawing the figure, we can use this. I, j, k. So I cross j is k, j cross k is I, and then I cross k is minus j, k cross j is minus I, in that order, right? So let's work it out. So this becomes I cross k is minus j, so a minus and minus becomes positive, so that becomes a 215 dx, a 215 dx j, and then j cross k is just I, so it's just minus 215 dy, 215 dy I. Okay, great. And then replacing FA in the resultant there, let's work it out. Summation of the resultants, once we replace FA, since the FA here, let's replace FA, we know the value, and FB there, we do the same there, so that we find the final solution. So we'll have minus 14 by 6.75 minus 35 by 0.75 minus 495. So this gives us a minus 7, gives us a minus 791.25i, okay, plus that's 40 by 5.75 plus 35 by 5.75 plus 330. So this gives us a 761.25J. So like you said, we are now using this equation. We are saying R this moment arm cross F, resultant in the Z is supposed to be summation of the resultant moment. Okay, you see this equation. So now we have to equate the two. So we are equating this part. We place it there like so, and we say equals. Let's write it properly. We just write it properly. So say minus 215. I want to start with the I. Dy I plus 215 dx j is equal to minus 791.25i plus 761.25j. So we are equating this part with this part and this part with this part. Alright, that's what we are doing, creating two equations so that we find the unknowns. Therefore, minus d15 dy will be equal to minus 791.25, and our dy is just going to be equal to let's plug it in, 791.25 divided by 215. This gives us a 3.68 meters. Do the same. 215 dx is equal to 761.25. The dx is just going to be equal to 761.25 divided by 215. So we get a 3.54 meters. Alright, so found the position. So let's go to case number 2. Case 2, which is 4-133. In this particular case, they are telling us that the resultant force is required to act at the center. So if that is the case, we will need to find the center position of our slab. So we'll need to find that. So let's write our new moment arm. So the center along the X is going to be equal to 2.5 plus 0.75, which is 3.2. So 3.25 I. Then along the Y, it is 3.75 J, right? That's the center along the Y, right? Because the whole length is that's 7.5 divided by 2 is 3.75, and the whole length on the other side is 6.5, which is half is 3.25. Okay, that's fine. And then we have the resultant. Our resultant, since we want to find FA and FB, our resultant as a vector will be like this. It will be minus FA plus FB plus 140. Okay, I've put a negative there. It's all facing down. Alright. So now we'll need to cross that and then later on equate it to the moment that we already have in terms of FA and FB. So let's start with crossing this part. FRZ, and this is equal to 3.25i plus 3.75j, okay, cross minus FA plus FB plus 140. So this is going to be equal to, so using the same convention, I cross j is equal to k, j cross k is equal to I. In the opposite, we're going to have minuses. So 3.25, so this will give us the 3.25, that's j. J cross k, there's a k there, sorry. There's a k there. These are, we are crossing two vectors. Okay. So this is going to be equal to, so I cross k, I cross k, I cross k, we are going to have a negative, we'll have a negative, we'll have a negative, so that negative will disappear. So we'll have 3.25 FA plus 3.25 FB plus 3.25 by 140, 455. Okay, so this is equal to J. Then J cross K will just be, it will be a minus, so this is going to be equal to 3.75 FA and then 3.75 FB and 3.75 that's 525. Okay, that's J cross K, which is an I. All right, so we'll equate the two. We are going to equate this part and this part here. Okay, seeing this, we need to equate these two. So the I is going to go with the I. Where is the I? The I. And then the J is going to go with the J. We are equating this and generating two equations. All right, let's do that. Let's start with the I. All right, so we start with the I like we said. I, there is a negative, don't forget there is this negative here. See this negative? Don't forget that. So have minus, so this is minus 3.75 FA minus 3.75 FB minus 525 equal to, it is the I on top, that's a minus 6.75 FA, okay, a minus 0.75 FB and a minus 495. So let's simplify this. So we have minus 375 plus 75 this we get a 3. So we'll have a 3 FA, and then we have minus 3.75 plus 0.75. We have a minus 3 FB. Alright, so this equal to minus 495 plus 525. We have a 30. Okay, is that so? So we had a minus I and a minus I that side. So let's simplify this. We can write our FA as equal to FA as equal to FB plus 10, right? Then the second equation, this is our first equation. Second equation is in green. It's in green with this part here, of course, and this part there. The two. Let's start with the bottom one. 3.25 FA plus 3.25 FB plus 455. This is going to be equal to 5.75 FA plus 5.75 FB plus 3330. Okay, so this therefore gives us 3.25 minus 5.75. We'll have a minus 2.5 FA. Okay, and this also we are going to have a minus 2.5 FB. This is equal to, that's the 330 minus 455. This gives us a minus 125. Okay, so what we need to do now, we want to replace FA. We replace FA here. We replace it there. And if we do so, then we are going to have FB equal to, let's replace it. So we'll have minus 2.5 times 10 plus 125 and divided by we have a 2.5 by a 2.5 FB and a 2.5 FB. Okay, so this gives us a 20 kilonewtons. And since we found the 20, we can replace FB here. We know what FB is, so we can replace what FB here. We can replace FB. And once we do so, we'll find that our FA is just going to be equal to 30 kilonewtons. Alright, so let me just outline the final solutions. We have our location. We have a dy there. We have dy. That's the location For the first case, dy and dx, okay, in the xy plane, xy slab, and then we have the value of let me finish off the resultant. Therefore is going to be equal to, we are also asked the resultant, right? The resultant is going to be equal to where is it, minus, we said it's minus fa plus fb plus 140. Yes, therefore the resultant is just going to be equal to, the resultant in the z-axis is just going to be equal to, we need the resultant also. This is going to be equal to, that's a 50 plus 140, that's 190, right? So minus 190, or we can just write 190 like so, 190 kilonewtons, and then just say it is facing down like so, and so are all these, they are all facing down. Okay, so let's circle them. So this is 190, right? So we have fa there like so, we have fb, we have the resultant like so. I think this is about it. We found the resultant false, we have found the components of f and fb, we found the location in case number 1, and I hope this particular video was of help. And if it was, you can give me a thumbs up, share my video, and continue subscribing and spreading the message. Bye bye, and see you in my next screencast.